So good evening guys. So in this class we are going to concentrate on Newton's law of motion. Okay. So up to now what we have completed: units and dimensions, measurements and errors, motion in a straight line and motion in a plane. And we are going ahead of the chapter that is laws of motion. Okay. So the first thing we are going to see what is force. So in basic classes we have studied about the forces, right? Forces, right? No, like in 8th, 9th and 10th. Either it can be a push or a pull. Yes, no? So either it can be a push or a pull we have studied. And what is the image showing over here? What is the thing they are doing? Pulling the string, right? No? So some force has been stored, like energy has been stored there. Yes, no? If the archery, like if the arrow is left, no, what will happen? Kinetic energy will be there. Yes. So what is the person doing over here? It is like the person is pushing here, right? No. So either it can be a push or a pull, the basic definition of the force, right? No. So let us discuss about the types of force now. So the types of forces like electromagnetic force, gravitational force, contact force and nuclear force. Okay. So the main thing which we are going to discuss in this chapter is nothing but like gravitational force we will discuss in class 11th in upcoming chapter, and electromagnetic force will be discussed in class 12th, and nuclear force also will be discussed in class 12th. Okay. So the contact force, either it can be a normal reaction, tension or a friction. Okay. This is the thing we are going to discuss in this class. Okay. So when we go ahead of the topic now, we'll discuss what is normal reaction or normal force, tension and friction. And one more force is also there due to gravity, that is weight we will say. Right? So these are the forces which we are going to discuss. So under friction also we will see some types like static friction, kinetic friction and rolling frictions. Okay. So when we go into the topics now, we will discuss detailedly about that frictions and all. Okay. So you can take note of this. So suppose if object is there, simply they kept as it is. So is there any force acting on the object? No. Depends upon gravity. Yes. Something is pushing me down, like I am in the surface, and one more normal reaction will be there. That one we will discuss. But when we are not discussed about the types of force, I will keep aside. Is there anything acting over there? Nothing. Right? No? I am not discussing about this one first. I have discussed about only force now. Either it can be push or pull. When we have discussed about push or pull, is there anything acting over here? Nothing, no. When we go into the topics of force, when we see the diagram, no, the forces will be there. Due to gravity, there will be some force, and due to the surface, a contact, some normal reactions will be there. Okay. Done? Yeah. Now, to move a football at rest, we need to kick that ball. So what's happening over there? I am pushing or pulling the ball? I am pushing the ball. Right now? Right now. So to throw a stone upward, what I am doing? Pushing the stone towards upwards. Right now. So some external agency is needed to provide force to move a body from rest. Right or no? It can be either a push or a pull. So consider a ball is rolling down an inclined plane, and to stop the motion apply a force against the direction of its motion. So simply if I keep the object, no, there is nothing acting there. Because of the inclined or declined plane, it is going down. Right now, due to the declined plane, it is going down. If I want to stop that ball, what I should do? External agent should be there to stop this ball. Right now. So external agency is needed to retard or stop motion. What is the meaning of retard? The meaning of retardation we have seen, no, in straight lines we have seen like acceleration and retardation. What is the meaning of acceleration? It is positive. Retardation is negative. So what we can understand over here, if this is coming with some acceleration A, what acceleration I should apply to stop that? Minus A. Right, no? That is the meaning of retard, no? Retard are to stop the motion. Any doubt over here? So a stone is released from top. What will happen?
Gravity pulls the stone.
Obviously, due to gravity, it will go down. So a bar magnet attracts iron nail from a distance. Yes, no? Is there any contact between these two?
No.
Nothing. If I leave something over like this, it will go down automatically. It is due to gravity, we will say. If I keep some iron material over here and some magnet over here, if I bring together, near to the together, no, I am not going to be contact with them. But if I get together, what will happen? It will try to attract. Yes, no? So what we can understand by these two examples over here, a force is there, it can be a contact or it cannot be a, it may be or may not be contact also, right, no? So that's the main thing. Stone accelerates due to gravitational pull of earth, and external agency can exert force on a body even from a distance. Like if I want to apply if I want to apply force, no need to touch or no need to be in contact also, right, no? Yes or no? That's the main motive of this two examples I kept over here. So the external agency may or may not be in contact with the body. Got it? So why we have taken this example now? We have discussed about the forces there, contact forces. So when we go to the point now, I have told one more force, that is weight. It is due to gravity, right? So due to gravity, in the sense, this is what force now? Not contact force, no, non-contact force we can say, no. So contact force and non-contact force. So non-contact force, one we have seen, one is gravity, second one is magnetic, right, no. So that force will be seen in the class 12th, and that in non-contact weight will be, that is due to gravity, will be discussed in this chapter. Okay, you can note a point over this. So this is my non-contact force, and basically due to gravity, right, no, gravitational. Electromagnetic, that's what I told, will be discussed in class 12th. Electromagnetic and the gravitational is in class 11th we will discuss, like what is particularly about the gravitational. Okay, so basically we will see due to gravity, that's it in this chapter, and nuclear force also will be discussed in class 12th. Okay, so any doubt now why we have taken this weight and why I have not explained in the starting slide? Got clear? So any doubt over here now? No, right? Can we go for the next one? Yeah. So law of inertia. The next topic is law of inertia. Okay. So let me consider a body with a velocity v. Okay. So we need an external force to stop or retard the vehicle. So what is the meaning of retard? I have told
Negative.
to be negative acceleration to be applied. Okay. So suppose if I consider this object is going with F is equals to ma, what force I needed to apply over here to stop? F is equals to, minus F I can keep, no, that's it. Equal and opposite, no, that's what. So F is equals to minus ma, that's it. So the vehicle, like a friction or a brake. So brake, if I apply, obviously it will stop. So object is going with 20 meter per second. If I apply less brake also it will stop. But object is going with 200 meter per second or 200 kilometer per second. If I apply less brake, will it be stopped? No. I need to apply more? Yes, no. So we need an external force to increase the speed. No external force no change in its velocity. Okay. What we can say here? suppose object is going with velocity v, it will be in velocity v only until or unless an external agency is applied on it. So if I apply force, it will go fast. If I apply force in this opposite side, it will stop. Retard. So one thing here, velocity, if I apply force, increases. If I oppose it, velocity decreases. So what we can say? Law of inertia. A force, object is in motion or it been raised unless or until an external agency has been applied over there. Right now? So this is the Newton's first law. Right now? So law of inertia or Newton's first law we will say. So inertia means resistance to change. So a body does not change its state of a rest or uniform motion unless an external force applies on to change the state of that. Okay. So neither, if I see here a body has been accelerated, which means I kept the object, it has went down. So obviously if I keep same inclined plane over here, no, it will retard there. Yeah. So if I leave here, obviously it will go to the opposite side of the inclined plane. Same height, no? Yes, no? So if I keep this balls to over, in this flat surface, what will happen? It will neither move. Yes, no? It will neither move. So no external force, no change in its velocity. Here, is there any external force is acting over here? Yes. What is that? Inclined plane I have kept. Due to gravity it's going down, no? Yes, no? So we have seen something object, if I leave like this, it will go down. So I have taken to some height now. Obviously it will go down. Right now? Yes. So a body does not change its state of a rest or a uniform motion unless an external force acts on it. Okay, this is the Newton's first law. So what we can say here, more mass, more inertia, can I say? More mass, more inertia. If I take a 5 kg ball and if I take a 500 gram ball, okay, if I apply a force over here to stop, that is F is equals to 5 Newton, let me take here, to stop this one as F is equals to 5 Newton. Can I apply same force over here? I have applied 5 Newton to stop the 500 gram ball. Can I take the same force to apply apply to stop the 5 kg ball? Yes.
No, but it will not stop completely.
It will not stop completely, right? But it will be in motion only, no? I am asking whether it stop or not. No. So what I can say, more mass, the important point over here is note point. More mass, more inertia. Okay? So any doubt over here now, up to now? Now we will see the example, what we have done here, I will keep in this slide, okay. Now, if I take the ball over here, the same slope is there, no, here. What will happen? Here slope has been decreased gradually, again increased gradually. If I keep a ball, it will go to the same height. Here slope has been decreased. Okay, I have taken the height here and the same height here, but if I see the traveling path, no, it has been changed. But again, it will reach the same height. Yes, no, because there is no external forces acting over there. So here zero friction, here also zero friction. If friction is there, what will happen? The object's velocity will be decreased, which means opposing force. Friction is opposing force, no? In basic class we have studied about the friction, which is nothing but opposing force. So here zero friction, here also zero friction, which means it will not change. It will going with the same velocity only. Yes, no? Yes. So final height is equals to initial height. Here also ball will be reached the same height. So when I take a zero slope, what is zero slope which we have seen in the graphs? A line which is parallel to x-axis. Yes, no? A line which is perpendicular to x-axis, it is infinite slope, we'll say. Right, no? So when I keep a ball in like to the inclined plane and the slope has been decreased now, it has been flat. So what will happen? A ball will go with the same velocity. It will go to the distance, infinite distance. Yes or no? So unless and until an external force act on it. So Galileo proved that on the frictionless horizontal plane, body travels with uniform velocity. Okay? Can we go for the next one? Yeah. So I have explained over here. So when a ball rolls down one side, it climbs up the other side, assuming no friction. So final height will be equals to initial height. So the ball always try to reach the same height from the which the started. So demonstrated conservation of energy. Okay. So here what is the conservation of energy means? What is the meaning of conservation of energy?
Potential energy is converted to kinetic energy.
Whatever it is, but there is no loss of energy, we can say, no? Yes or no? There is no loss of energy. If friction is there, what will happen? If some hard surface I have taken, I am trying to rub over there, what will happen? Heat will produce. Yes, no? Hard surface in the sense friction surface. Yes or no? There is no friction, which means energy will be conserved. Yes, no? So next one, slope decreases. If the opposite slope is made less steep, which means more gentle. Okay. Steep in the sense slope has been decreased. Okay. The ball still rises up to the same height, though it travels a longer distance. Okay. Next one, slope equals to 0. A ball will go to the infinite distance with the same velocity. Okay, understood, no? So next one, we'll see what is type of inertia. We have seen inertia. What is inertia? Forgot, that's it. Resistance to change, no? Resistance to change, and one more thing is more mass, more inertia. 2 points. Now we will see what is the type of inertia. So in type of inertia, we are going to discuss about two types. One is inertia of rest, inertia of motion, and the first one we are going to discuss is inertia of rest. Okay. So it's the inability of a body to change its state of rest by itself. Okay. So passengers standing in a stationary bus experience a backward jerk when the driver starts the bus suddenly. So what happens when we are inside the bus? A bus is there. You went to bus stop, a bus is there. You have you have seated down now. Okay, no. You have sat in the bus, and what will happen if a driver starts suddenly? We will move back, no? Yes, no. If a driver stops suddenly, what will happen? We will go front. Yes, no. So this happens because of the feet of the passenger in contact with the bus comes into the motion, but the upper part of a body continues to be at rest. So what is the thing here we can understand? When we are in contact with that bus only, the object or a person is going back. When bus is going forward. Right, no? If we are not in contact, what will happen? Nothing, no? Same thing like if we talk about a space, okay, there is no contact, no, with the space and the surface. Yes, no? If it goes with any velocity or anything, there is no contact, nothing will happen. We will go forward or we won't go backward. Yes, no?
Yes.
So suppose a coin is placed on a smooth piece of card, placed on a glass tumbler. Now a person is trying to push that or flick that card. What will happen over there? If the cardboard is struck suddenly, the cardboard slip away, but the coin falls into the tumbler. This happened because of the inertia of rest of the coin. Only I am moving this one. This body is at rest only. So it will fall down. There is no magic over there. Yes, no?
Yes.
It is physics. Right now? So object like the paper has been pushed over there. So the coin will go down. Okay.
Sometimes the coin moves with the paper.
Because the amount of force which we have applied is less. Yes, no? When the coin is going forward or it is slip over there, what happening there? The force which I have applied is less. Which means the black magic I have learned is wrong, we can't say, no? Yes, no?
So or the paper has more rough.
Maybe, yes. So inertia of motion, next one. Okay, so it is the inability of a body to change its state of a uniform motion by itself. What about that one? Uniform rest, no? Like it was in rest. Now a body in motion can neither accelerate nor retard on its own. Passenger sitting in a moving bus experiences a forward jerk when the driver stops the bus suddenly. So this happens because of the lower part of the passenger in contact with the bus comes to the rest along with the bus, but the upper part of a body continues its motion. Continue its motion. Right now? Like a driver applied a brake suddenly, but you went forward. It has been stopped, but you are in forward motion only, no? Yes, no? That's the point they have explained over here. So two things we have studied. One is law of inertia and then types of inertia. Resistant to change its motion or rest. So inertia of rest, inertia of motion, two types. Okay. Now we will see what is the direction of inertia. So it is okay, the same thing, direction of the change its direction of motion by itself. A body continues to move along the same straight line unless or until some external force act on it. Yes, no? So if I am going with or if I pushed something, okay, I have kept some stick over there like this, I have thrown like this, so it will go in a straight line. Yes, no? Unless and until some thunder or thunderstorms are acting over there. Yes, no? Cyclone will come, because of that cyclone it has been moved somewhere, right? No? So some external force should be there to change its direction, unless or until it will go in the straight direction, right? Now, so string continuously apply a force on a sphere towards the center. What it means? Like the first one, consider a small solid sphere connected to a string in a circular motion. If I take a string, no, and if I rotate like this, what will happen? A circular motion will take place. So what they are saying, string continuously apply force on the sphere towards the center. So if I apply force only, the ball will or the solid sphere will move. So like the forces towards center only, no. If I apply like this, I am something rotating like this. So the force will be towards me. That is centripetal force, we will say. That one we will discuss in the circular motion. Okay. So this force helps change the direction of its motion sphere continuously to keep its circular motion. Okay. So two things we are going to discuss in circular motion. One is centripetal and one is centrifugal. Okay. And that one will be discussed in vertical or horizontal circular motions. Okay. If the string snaps suddenly, the sphere moves tangential to the surface. What is the meaning of this? Snaps suddenly. I am rotating like this. Okay, I am rotating like this. So what is the direction of this sphere? How can I mention is, this is my solid, this is my circular motion. If object is going in this direction, we will consider. Okay, this going in anti-clockwise direction we will consider. Suppose object is here. What is the direction if I want to see? Draw a tangent over there. If object is here, draw a tangent over there. If object is here, draw a tangent over there. Okay, this is my direction. If in this position object is there and if I left suddenly, what will happen? The object will go like this, sir, in the straight line. That's what you have told. No, if the string snaps suddenly, the sphere moves tangential to the surface. Right now, whatever position I am living, in the same direction it will go in the straight line. Right now? Now, Newton's first law of motion, that is law of inertia. So, every body continues to be its state of rest or uniform motion in a straight line unless or until an external force act on it. Okay. So, this is what I was telling, like Newton's first law can also be called as law of inertia. Okay. Take it down. We'll go for the next one. So, consider a book placed on a table. So, weight is the force acting on the book due to gravity, and a normal force R is acting on a book by the table. So, let me explain before that what is weight and what is the normal reaction. Okay. Yeah. So, first one we have seen a contact force. Okay. First one we have seen a contact force, right? So, in contact force what we have seen? One is normal.
Tension.
Okay. Next one is tension.
Friction.
And then is friction. Okay. So, in non-contact force what we have seen? So, yeah, magnetic force we have seen, but what we are going to discuss in this? Weight.
Due to gravity.
Due to gravity, yes. So, now when we are talking about the normal force, no, like everything is SI units is Newton. Okay. So, when we talk about the SI unit of the force, no, so force is nothing but mass into acceleration. Okay. So, kg meter per second square or else Newton. These are the SI unit of the force. So, when we are talking about the contact force and non-contact force, thus we have seen the types. So, everything will be having the same units. No, normal force, tension is a force, friction is a force, weight is also a force. Right now, this also will be having the same SI unit, that is Newton. So, when we are talking about the normal force, okay, it will be acting perpendicular to the surface. Okay, perpendicular to the surface. When I am talking about the tension, where the tension acts is when I am handling the string, a rope. Okay. So, string or rope. Okay, so how a tension force will be acting? It is acting away from the body, acting away from the body. This is my tension. What about the friction now? Friction is the opposing force. Opposing force acts opposite. Yes, no, acts opposite to the body. Now what about the weight? It is due to gravity, always at center of earth or towards the center of earth, right now towards the center of earth we'll say. So these are the things. Let us keep a symbol for this now. So normal reaction N, tension T, friction small f, and the weight is W. Okay, we will see use this symbol in the upcoming slides and the problems. W. Okay, take a note of it. Done? Can we go for the next one? Okay. So let us discuss now. If I have a surface over here and I am keeping a block like this. Now what are the forces are acting here? So obviously when I talk about the object, no, any object, gravity will be acting. That is weight. So how can I mention that? Towards down. That is weight. Now let me check the block is in contact or not. Yes, no? So one is non-contact force, always will be acting. Now the block is in contact with the surface. So this is my surface, right? This is my surface. Now the normal reaction will be acting, which is perpendicular to the surface. So which means in this direction normal reaction will be acting, right? No. So this is one thing. What I can say is the weight will be mass into acceleration, that is due to gravity g. Weight will be mg. So here n will be equals to mg, can I say? Yes, no. Now the second example what I am going to take is an inclined plane having an angle theta. So here I have kept a block like this, a block having a mass m. So in which direction the weight will be acting? Towards down. So like this exactly I need to draw weight now. Now in which direction, the block is in contact. In which direction the normal force will be acting? Perpendicular direction. So perpendicular means it will be in this direction. No, it should not be like this. Perpendicular to the surface only. So I should take a normal reaction in this manner. So in this case, normal reaction is not equals to weight. Yes, no? Yes or no? So what I should do here? I should take the component for this. Right now I should take the components for this. So I will give a simple trick to overcome this. Take 8 parts like this. Okay, take 8 parts like this. So exactly you take this and keep the triangle wherever it's fit. So I'll keep the triangle and it is angle theta. So keep the angle theta alternatively. So theta, again theta over here, theta, theta, again theta. Got it? Now take the weight, that is mg, towards down, no, always towards down, mg. Now where mg is there and see the angle side by. So where theta is there, that will be my cos theta. Where theta is not there, that will be my sin theta. So this is my mg cos theta and this is my mg sin theta. Right? Now I can draw that. So if I extend like this is my mg cos theta and this is my mg sin theta. So now I can say no, n will not be equals to mg, but it can be equals to mg cos theta. Right? Take a note of it. Done? And let us discuss about the more example when we keep the block over the block and block adjacent blocks. Okay. Completed, no?
There n is not equals to mg cos theta.
No, it will be equals to mg cos theta. So n will be equals to mg cos theta. It will not be equals to mg. Okay. Like in this case, it will be equal. Like normal force and the weight will be equal. But in this case, the normal is acting some angle, weight is towards down. So if I take like this, no, something like this, it is not equal. It should be equal in the sense in the straight line. Right now. Got it? Now let me take a surface like this. There is a block A and over that I am keeping another block B. Okay. So whatever we are drawing from this, no, that is free body diagram, will say. Okay. So keep a topic. For the previous case itself, it is only free body diagram. Okay. Free body diagram, which is nothing but FBD. Okay. Done. I'll take a block A and block B. Now I'll take a separate block, like block A separately, block B separately. Now I'll take a block A now. So when I talk about the block A, what are the surfaces are there? Two surfaces. One is the ground and one more is block B. Right now. So due to block B, before that let me take that weight. Mass of A into gravity. Right now. Now the normal reaction due to surface, that is N. Right now. So one more surface is there. This is my first surface and this is my second surface. So due to this also one more normal reaction will be there. This is normal reaction due to B. Due to B. Right now. So let me consider this is N dash. Now if I talk about B, now how many contact surfaces are there for B? Only one contact, that is A. So in which direction I should draw? Like this, perpendicular, no? So N dash. Okay, now the block is having a weight also, which is mass of B into gravity, right now. So when I talk about A, two contact surfaces, one is ground and one more is block B. When I talk about B, only one contact surfaces, that is B. Okay, so if can I write like this, the normal force N is equals to MAG plus N dash when object is in equilibrium condition, like it is in rest now, nothing is acting over there. Okay, nothing is acting over there. So in this condition, N dash will be equals to mass of B into gravity. So the total normal force will be equals to mass of A into gravity plus mass of B into gravity, which is nothing but MA plus MB times G. This is my normal reaction. No, suppose this is the surface. What is the total mass? Mass of A plus mass of B, and the gravity for this is G. So should be equal to the normal reaction. Am I getting the equation now? Take it. Done. So when we take a 3 blocks, what will be the equations we'll see. Okay, so now I am taking a 3 blocks. So this is my surface, this is my block A, and this is my block B, and this is my block C, looking like cake, huh? Okay, now draw the free body diagram for these 3 blocks now. Okay, so before that, how many contact force for the A? 2 contact. One is ground, one is B. When I talk about B, 2 contact. One is A, one is C. When I talk about C, only 1 contact, that is only C. Okay, I mean only B. Now I need to draw the free body diagram. So let me take a block A. So a normal force due to surface will be towards up. This is my normal, and weight will be acting towards down, no. So that is my mass of A into gravity. And what is the another normal force in which direction it will be acting? Towards down. Right now it is due to block B. That is, let me take one M dash. Okay. Next I will go for the block B. So when I talk about block B, weight will be acting MBG towards down, and the same opposite force should be in the upward direction, that is N dash, right now. And one more normal force, no, that is N double dash I will take. Okay, what about the block C? Block C will be having mass of C into gravity and a normal force which is N double dash. Is there any other thing acting over there? It is in equilibrium condition, let us assume, which means object is at rest. Okay, so now if I write the equation, N should be equals to N dash plus mass of A into gravity, and for this N dash will be equals to mass of B into gravity plus N double dash. When I talk about this one, N double dash will be equals to mass of C into gravity. Right now, when I take this equation, substitute here, and if I consider this total equation and substitute in first one, what will happen? N will be equals to, so MAG I will write as it is, M mass of A into G plus, what is N dash now? N dash will become MGB plus MCG. So mass of block B into gravity plus mass of block C into gravity. What is the total equation now? The total equation will be normal will be equals to mass of A plus mass of B plus mass of C into gravity, right? So any doubt over here now? Take it. Done? So till now we have discussed free body diagram for a normal force and the weight. Okay, so weight will be common for everything. If I keep an object, weight will be acting towards down. Okay, so next we will see a block kept like this, another block is contact in this manner. Now there is a surface. Okay, there is a surface and this is block A and this is block B. Now if I want to draw the free body diagram, I am taking a block A now. Block A will be having two surfaces. One is ground surface, one is B surface, no? So my weight will be mass of A into G and this one will be normal. And one more normal, in which direction? Down or up? This is my surface, I have taken the normal perpendicular and now this is my surface. In which direction I should take now? In this direction. Okay, now tilt in this manner. So block B is like this, block A is like this. So this is my surface, no? So it will be perpendicular, no? Got it? So a normal reaction, that is N dash I will take. Got it, no? So now block B having how many contact surfaces? One is A, one is ground. So one weight will be there, that is mass of B into G, that is a normal, let me take double dash, N double dash, okay, and this is my N dash. So there will be equal and opposite force, no? When I apply a force in this manner, for example, if it is moving together, which means there should be equal and opposite force. Yes, no? So any doubt over here when I consider a block like this? So previous case what we have done? We kept a block upon block. In this case, we kept a block adjacent side. Okay. So the same thing I will take for a 3 block. Block A is there, block B is there and block C is there. So before that we will write the equation for this. So N will be equals to MAG, N double dash will be equals to MBG, and if I apply force only I can write the equation in this case. Okay. Now let me draw the free body diagram for this. So block A, what are the forces are available? One is normal force, one is weight. So weight will be towards down, no? Mass of A into gravity and the normal due to A. Okay, and one more thing, due to B, that is N dash I will take. Next one mass of B. So normal reaction will be there by B and weight will be there. And how many surfaces are there for B now? 2. 3 surfaces. For A 1 and 2, for C 1 and 2, for B 1, 2, 3. Okay. So one normal force in this direction N dash, one more normal force in this direction N double dash, due to C N double dash, due to A that is N dash. Okay, now for C, how many contacts are there?
2.
So one is normal to the surface and one will be weight, that is mg, and in which direction it is? Towards right. So this is my normal n double dash. Okay, take it. So we'll stop up to here and we'll continue the next class about the tension. Okay, we'll meet in the next class. Bye.